Hello, in this presentation I'm going to demonstrate the conversion of a Jupyter notebook with Python code into a Mathematica notebook with Wolfram Language code. We're going to use the Jupyter notebook provided by Vadim Smolякov in a presentation he has put in YouTube about Monte Carlo integration. Vadim provided the notebook, as I said, in his dedicated GitHub repository for this presentation, and I have taken that notebook here. I have a copy locally running on it, and so you can see. Let me run all of the cells. Let me save, and so I'm going to be ingesting this notebook here, and I'm going to convert it into Mathematica notebook. We're going to do this in two different ways. One is to use large language models. The other one is to use dedicated tools for conversion. So first let's read the notebook, and you can see that because of the embedded images we have this large base 64 string, and I don't want to use that. I don't want to send such a large text because of possible limitations with tokens from the large language models, and so I'm going to delete all outputs here. So I just want this. I'll try to convert with ChatGPT just this notebook into a Mathematica notebook. So let me reingest this. You can see it's much smaller text. And so here I'm going to some previous computations here. All right, so here I'm going to convert that notebook. You can see in this function LLM synthesize, I say convert the following Jupyter notebook into Mathematica notebook. I'm using this NB Jupyter variable, which I ingested, is the ingested notebook is being assigned to. And I'm using this function or prompt function, nothing else. So ChatGPT and other large language models, they tend to be giving too much decorative explanations before and after what we actually ask about. And so you can see here this nothing else UL. It's modifying the prompt and telling the large language model not to be producing redundant texts. All right, so we got this result here. Let's see, can we run it? So again, although I said only Wolfram language code, you can see we have some markdown decorations here. But anyway, so and something is. All right, yeah, this is pretty close to what we observed since this rational numbers and square roots might be harder to judge. Let's actually compute the actual numerical values, so we can see we get the estimation of pi, and it's pretty close to what we saw in this notebook, right? So if I rerun the whole thing here, yeah, this estimate is very close. All right, so the alternative to this LLM generated large language models generated code is to use and integrate. I'm more or less using the same formula here with the unit step and making this logical restriction to the circle to be inside this disk, and so you can see here X is running from minus radius to plus radius, Y from minus radius to plus radius, and then we have this unit step specification. So I can gather, or I can collect the points which are used in the Monte Carlo integration. I'm using the same number of points which are being used here, this num iter, right? And so you can see we have nearly the same number of points, and I can plot them here. So. All right, so how we can do this in a dedicated manner? So I'm going to use, so just a moment, first to convince you, I have this converter which takes Markdown and converts it to Mathematica notebook. And so here I'm going to use this function pbcopy, which is going to put it into the clipboard. And so here I'm going to just try to paste it. Mathematica is asking me, do you want to produce a separate notebook? I said yes, which went to the other screen of mine. So I drag it here. And we get the corresponding Python code into the corresponding Python cells. When I evaluate it, you can see we're getting from these cells here 190, we get this output. All right, so now I want to take this theoretical code, so to speak, and translate it, right? So I'm going to make another cell here. First, let me make this to be chatbook enabled. I'm going to make a chat cell. I'm going to dictate. Convert the following Markdown and LaTeX code into Wolfram Language code and formulas. And I'm going to paste this, which is not exactly what I wanted. Let me take this part here. So the idea is to get the Mathematica formatting for this. So with formulas and so forth. While is this thinking about stuff, I want to check which model is being used, and I want to make sure I want to use some of the more contemporary models, because this is not exactly what I wanted. And so I'm going to rerun this, and if this does not produce the formula type of expressions I wanted, which it doesn't, I'm going to show you some previous result here from previous executions. But I basically at some point I did convince it, or just rank it several times. I did produce this kind of more theoretical, more formula like looking outputs. All right, so this was it. Thank you for your attention.